All right, so we're going to jump into heating systems. When you're out in houses, there are going to be lots of different types of heating systems that you're going to come across. I always make the joke that here in Maine, you're not a true Mainer unless you have at least 3 sources of heat, right? So there's going to be a lot of options here. With a lot of the mechanical systems you'll see in the picture here, there usually is a manufacturer spec plate that has information about the heating system on it. This is definitely information that I always try to capture when I do an audit. But you can see here the main thing that I always want to know is what is the power of this unit? What is the power? How much heating capacity does it have? And it's always rated in BTUs, which is British thermal units. That's what we use to measure the heating capacity of different heating systems. So for this case, it's tiny on my screen, but 184,000 BTUs. That is a tremendous amount of heating power. That is a lot of, that's just like brute force heating. You know, if you have an old uninsulated house, 184,000 BTUs will do it. But then if you go through and you insulate the house and you make it a lot tighter, then 184,000 BTUs is ridiculous. It's way too much power. So that's where, we look at using heat pumps instead. That heat pumps would be much more cost effective to use. So we look at, the heating capacity of the unit. There's a lot of other information on there you don't need. If you want to capture the model and serial number, then you can actually look that up online. A lot of the manufacturers have, there's a database online that if you have the model and serial number, you can find out exactly what the age is if you wanted to do that. So heating load in a house, when it says 184,000 BTUs per hour, what that's really meant to do is to replace all of the heat that is escaping, right? So if we built our houses like a thermos, where it had very little heat load or heating loss, then the boiler would hardly ever have to run. It's only because we're trying to replace the heat that is escaping our house through all these different surfaces. So we talked about a lot of the ways that happens in the last presentation that I did. All right, so different heating system types. This is representative of much of what you're going to see. There's forced hot air systems, there's forced hot water systems, steam systems, heat pumps, and there's some geothermal that you're going to see, ground source heat pumps, and then of course also fireplaces and wood stoves, pellet stoves, and whatnot. But maybe some of you have had experience with heating systems, and you can come into a house and you'll know when you come into the boiler room what you're looking at. But when I first started as an auditor, I didn't know the difference between a boiler and a furnace, which was kind of funny because I'm supposed to come into the house like the expert, like I know what I'm looking at, right? So hopefully, we go through this and hopefully it'll be helpful to you guys. So let's see, Rob's not here, so I can pick on him a little bit. So we did the energy audit at Rob's house earlier. So he has a forced hot water system. He has a boiler. This is the thing, everybody calls it a furnace. If you ask how you heat your house to homeowners, they're going to tell you it's a furnace. A furnace is forced hot air heating system, ductwork, comes out in vents. This boiler right here, everybody calls this a furnace. No, this is a boiler. It heats water that circulates through forced hot water baseboard pipes. So there is a difference. So now that you know that, forget what I just told you, because if you correct homeowners, then they're going to look at you like, why did I have this person come to my house? So the only time that it matters is if you have to have it replaced, then you need to know that you have a boiler or furnace. But otherwise, just go along with what people say. Um, I hate to like stand there and be a know-it-all with homeowners. So forced hot air is a furnace. A boiler does hydronic baseboard heating. It also does steam heat as well. I still see a fair amount of steam systems. Not a ton of them anymore, but I still see them, definitely. A lot of times you will see these steam radiators here that we see where those have been converted into hydronic heating. So it's just a regular boiler. It's not a steam boiler. Steam boilers are really fairly inefficient. So it's possible sometimes for people to convert the steam radiators over to hydronic. So it's just pushing hot water through it instead of steam. So you can do that. There's also the heat pumps, which we'll definitely talk about that. That is an air source heat pump, so it's pulling heat from the air outside and it's concentrating that using a refrigerant cycle, and then it pushes heat into the house. There's also what is typically called geothermal heat, so that's where you're pulling heat from the ground and using that to heat your house. That is not true geothermal. That's not actually geothermal. Technically, it's a ground source heat pump. Geothermal is like the big plants where they're pulling steam from the ground, like in Iceland, and they're actually generating electricity with that. But ground source heat pumps, that's what we usually refer to as geothermal. Geothermal, I don't see that often, to be honest. It's really expensive to install. Like the cheapest geo system I've ever seen was like $50,000. Typically they're like $75,000 to $100,000, which to retrofit that into an existing house, I mean that is a lot of heating bills before you ever see that money back. So yes, it does. Yep. Typically that's done by drilling either one or several wells. Hundreds of feet down, and then they just run the refrigerant tubing down into the well, and that picks up the heat. Yeah.
So I'm just wondering about this because I've kind of run across it in my own house. If you have a boiler or furnace or a heat pump and it has a BTU rating on it and it's 30 years old, how accurate is that? Do they drop off over time?
The efficiency definitely drops over time, and sometimes like you might see the yellow energy guide label on the side that says that it's 80% or 85% efficient. When the service technician comes and does a cleaning every year, hopefully every year, they'll give you what the efficiency is, and they'll say, oh, it's running at 85% efficient. That is just the burning efficiency of the unit. That is not the overall efficiency. The overall is probably much lower than that. So there's no way to test for that. That yellow energy guide label shows you like what the lab rating was for it when it was tested, but not the real world. All right, so I'll give you some examples of these different system types here. So forced hot air system. This is taking the air from the house, pulling it in through an air handler, a fan, inside the furnace unit. It's heating it up through a heat exchanger and then blows it back up into the house. So typically all of the rooms in the house will have supply registers. Those are usually smaller. And then there will be one or two larger return grills where it's pulling the air back to the furnace. Some of the benefits with furnace is that they heat up really fast. You turn the furnace on and you get heat pretty fast. Also, a forced hot air system ductwork can be used for cooling, for AC as well. That's never something that we've really cared about in the state of Maine. We never really needed it until now, as things get warmer in the summer. So newer houses are having central AC put in. You can also sometimes use that ductwork for installing a heat pump into that as well. So we'll talk about that in a little bit. Disadvantages for forced hot air system. It requires ductwork, which is not a DIY thing. You need someone to design that forced hot air system. I am shocked and amazed every time I come into a basement and see that the ductwork is actually insulated. Most of the time it is not. So you have a lot of heat loss in a basement. So if you guys ever come into a house with a ductwork in the basement and the basement is unfinished, then that's definitely a big recommendation you want to make to get those ducts insulated, because otherwise it's just heating the basement. Why? Why are you heating the basement? All right. Also, forced hot air systems require filtration. There are filters. A lot of times homeowners don't know, oh, there's a filter in this? Yes, it has to be replaced every 3 months. So obviously you take an old dirty filter out and it's all clogged, and all black and everything with dust, then that's what people are breathing in the house. And also that really slows down the air that's able to move through the system as well. So forced hot air system, it can be natural gas, propane, oil, electric. I never see electric here, but in the South it makes more sense. So there can be a number of different fuel sources for a furnace. Does not just have to be oil. All right, and then your furnace system here, the pink shows all of the distribution, the layout for the supply here. So you typically have 1 or 2 main duct trunk lines here, and then you have the branch takeoffs that go to each individual room. One of the issues with forced hot air systems is it's designed to blow air into the house and then pull it back into the furnace. But then if people, go around at night and close all the bedroom doors, then all of that air that's being blown into the bedrooms has a harder time getting back to the return. So you can cause pressure imbalances in the system by closing up doors and closing rooms off. So that can be an issue as well. All right. Just want to make sure that you guys, right, okay. There's like a bunch of notes on the side that you guys would put you to sleep here. All right, hydronic systems, forced hot air. So this is a boiler here. This is a gas boiler. So just like a furnace, a boiler can be heated with a number of different fuel sources. You have natural gas, propane, oil, electricity, wood, coal. You have quite a range here. The advantages with a forced hot water hydronic system, a boiler, is that it's quiet. Usually when a furnace comes on, you have the air blowing right on you. It can be kind of uncomfortable. It tends to be louder. But with a boiler, it's just circulating the water through the radiators or the baseboards here. It's a lot quieter. Also, it's much more even temperature control. So a friend of mine has a house with an oil furnace. That thing comes on, blasts you with heat, shuts off after 2 minutes, and then the house starts to get cold again, and then the thermostat wakes up and then blasts you with more heat. So it's really kind of inconsistent. A forced hot water system is much more consistent that way. Disadvantages is that, if you come home, you crank up the thermostat on the boiler, it's going to take a while. It's slow. It's not going to be as fast as blowing hot air in the house. So it's a slower temperature increase. Let's see, the radiators have to be unobstructed. So this is something you guys will see as energy coaches. People will say, this bedroom here is always cold. I don't understand. It doesn't get hot like the rest of the rooms. And then you go in the room and you see there's a radiator and there's a bunch of furniture and a bunch of toys in front of it. Yes, you have to keep that unblocked. You have to let the heat be able to circulate in the room. Let's see. And if you want to cool with a forced hot water with a baseboard boiler system, then you have to add ductwork. You can't run cooling lines through hydronic baseboard. So you still need ductwork. In terms of distribution, so most boilers have this kind of a fin type, fin tube here. Let me use my pen here. So this heats by air circulation. So there's no fan in baseboards. So the cooler air is being pulled in underneath here. It goes through the fin tubes here and heats up, and then it comes out the top. So then it's really all working on convection of that heat rising. So with hydronic systems, you can have forced hot water baseboard. You can do hydronic or radiant floor systems where the tubing is embedded in the floor. And then also you have steam radiators like over there. All right, steam systems. They can use a number of different fuel sources. Typically what I see in Maine is oil. So if you have these type of radiators, you know that it's steam because it's hissing at you and knocking and making all kinds of noises. It gets real hot. I mean, it definitely works very effectively. But especially if people have kids, then it can be kind of dangerous. It gets really, really hot. The old radiators are pretty unsightly. There are new radiation units that look a lot nicer, but most people have these old rusty ones here. So there's steam, but you're probably not going to see a lot of that. And then the geothermal systems, like I said, it's a ground source heat pump. This picture shows the radiant tubing or the refrigerant tubing put into the ground here. So these have a pretty high efficiency rate. So, where a boiler is like 85%, an oil boiler is going to be 85% efficient. A geothermal system can be 300% efficient. For every watt of electricity you put in, you get 3 watts of heat back. So they can be very efficient. It's just incredibly expensive to install. I mean, you have to drill several wells typically to put these in. And usually these are forced hot air systems that get installed. You also get the cooling as well. You can use it both ways, just like a air source heat pump. All right, yeah. Yeah. So the difference between for geothermal, the difference between vertical system in the ground where the pipes go in versus horizontal. If you're going to put it in vertically, you have to drill wells to put the tubes down. But you can, 6 feet below the surface, it's a constant 55 degrees pretty much. So if you just dig down about 8 feet, and then put all of the coil, the line coils, and then bury that, then you can heat it that way as well. The issue with that is you can actually extract so much heat from the ground that you freeze it if it's not sized large enough. So that can happen with those the horizontal loops, but not as much with the vertical. Yeah. Typically, you're going to see vertical, not horizontal.
I've always been curious about the difference between Cape Cod, where we came from, where it's mostly sand, Maine, where you'd be drilling in rock. Is it all consistently 55? And can you put a geothermal in with ledge and where it's all rock?
I think if you can drill a well, then you can put one of these in. But like I said, they're so expensive, I hardly ever... Yeah, I've come to a few houses where they have geothermal and they love it, but you still have a fairly high electric bill, though, because it's forced hot air. You have the ductwork, so you have the fan, you have the heat pump, the heat exchanger that is going to use a fair amount of electricity. So it's not like it's free heat. You still have a utility bill to pay. All right, Rob, we'll stop picking on you. You're here now. So let's talk some more about heat pumps. So I know Scott Libby was here and he covered a lot of this, but there's still a lot of questions. So I'll give you my 2 cents, and we can certainly talk more about that. So heat pumps at this point have pretty much the same efficiency as a ground source heat pump. So for most people, I would say, why would you spend $80,000 on a geo system when you can just do air source heat pumps, and it's going to cost you pretty much the same to operate, and it's probably going to be a lot cheaper to install. I don't see very many geothermal systems. I see a lot of heat pumps. Efficiency Maine has been really successful in promoting these, especially in a state where 10 years ago most people didn't know what these were, and now they've got a few 100,000 heat pumps installed already, and they just continue to put more in. So I heat my house with 2 heat pumps. That's all I have. I used to have propane as a backup. I never used it. I got really annoyed every time the propane company would show up and charge me a couple $100 to put a little bit of propane in the tank. This is all I use, and it works really well. My house is very well insulated. I've done a lot of air sealing in my house, so I can tell you that it can work really, really well, and it can be very inexpensive to heat. My highest heating bill last winter, I think my highest electric bill was $215 for the month, and that includes everything in my house. So when people have a heating bill of $600 or $800 for a fill-up, then I don't know how you do that. I definitely can't afford that. So heat pumps can be a really effective and efficient way to go. Yeah.
How many times have you done a blower door test on your own house?
Oh, all the time. Yeah. Yeah. Obviously, yes. I've thought about that. I got vetoed for sure. I don't really pull the blower door out to use at my house in the middle of winter because I don't want to suck all the heat out of my house. But thank you for doing that, though. Rob. All right. So, like I said, I had mentioned this before. One of the reasons that heat pumps are so much more efficient is that they are variable speed. They can ramp up and down as you need to. That oil furnace, it has one speed, and that's on. It comes on, blasts you with heat, shuts off. There is no running at 50% for most oil furnaces. It's just going to blast you with heat and shut off. So that's why it's so inconsistent with temperature. It's sort of like you're out driving your car. It takes 5 minutes for the engine to warm up before it really gets to be efficient. Before then, the efficiency is not very good. So with the furnace, comes on for 5 minutes and then shuts off. Right when it's starting to get efficient, it shuts back off again. So heat pumps, one piece of feedback that I get from homeowners who have new heat pumps, they'll say, this thing runs all the time. Right, it's supposed to. It's designed to do that. It's not going to close up after 10 minutes and then stop heating. It's designed to heat all the time, and it'll give you a little bit of heat if you need it. It'll give you more if it's really cold out. Heat pumps can do heating and air conditioning. I mentioned in the last presentation I did that I put them in for heating, but that cooling has just turned me into a giant baby. So I just can't possibly go outside when it's 80 degrees or higher now. Also, heat pumps are the only way for most people to be able to generate their own heat. If you have solar panels combined with heat pumps, that's where solar panels become really cost effective because most people don't have the back 40 to go out and cut wood down anymore. So if you can do solar and heat pumps together, that's perfect, really. And then there are a number of different, go ahead.
I'm getting better at this. You say that you can generate your own heat using solar PV panels. Solar PV panels make electricity.
Right. So it makes the electricity that you use to power your
So
heat
that's
pumps
what you
with.
mean?
Yes.
You can generate your own electricity
Yes.
to power the heat pump.
Yes.
All right, thank you.
Yep.
My question isn't so much with heat pumps, but also, this is Maine, we lose power, and people like to have generators. I know you can size it based on, how many watts your house is gonna need, but an average, say, 1,200, 1,500 square foot home that's run entirely on heat pumps, what kind of generator do you typically need for that?
So I'll answer that a couple different ways. So my house, I don't worry about being out of power. I don't live in the middle of the woods. I live on a main road. In 5 years that I've been there, we lost power for like an hour. And so my house is insulated to the point that it doesn't matter. If it's off for an hour, the house doesn't really cool down that much. I don't really have a lot of heat loss. So that's one thing. But most people do have something else they can use as a backup if they needed to. So if people get heat pumps, and I've had some customers, audit customers, who say, I'm going to tear out all the baseboards. I love my heat pump. And I say, well, hold on a minute. Hold on. Don't take them out yet. Go through a couple of winters and see. Keep it there as a backup in case you need it. I will tell people, set your oil or your propane thermostat back about 5 degrees below the heat pump, and it'll come on if it needs to, just automatically. You don't even have to think about it. But most of the time, the heat pumps are going to do most of the heavy lifting. So I guess, most of the houses you guys are going to come to, people have multiple sources of heat that they can use as a backup if they need to. All right. There are a number of different configurations, including the outside units. So you can have a single zone unit where one outside unit connects to one inside unit. You can have multi-zone units where you have one outside unit that connects to multiple indoor units. For the inside units, we have some pictures here. Here's the typical wall-mounted unit that you see. But there are also floor-standing units like this one at the bottom here. There's ceiling cassettes. There's mini ducted systems that they can put in. There's a lot of different ways to do it. So if you're talking about heat pumps and people say, I hate how these things look on my wall, there's lots of other options. You don't have to have that. I have one of these on my first floor, and then I have one of these in my second floor, and it works great. When I do presentations with builders, then I will always ask this question. If you are building a new house and you are building to code and you are really insulating the house well, because that's what's required now, if you are doing air tightness testing, which is required now, then why are you putting in anything but heat pumps? I just ask it as a challenge question. Why would you put in a fossil fuel-based heating system at this point? Even if you lose power, like in the like passive house, for example, like the super insulated, super airtight houses that are being built now, it can lose power for a week, and it's still comfortable because there's just no heat loss, or so minimal heat loss.
Even if you're up north, let's say, up above Bangor, Lincoln, and heat pumps still recommended, even though it's, I'm going to say, significantly colder than it is here on the coast?
When I first started working at Efficiency Maine in 2020, one of the facts that they loved to tell people was the highest number of heat pumps in Maine per capita are in the county. Yep. Because one of the things that helps in the county is all new construction is actually built to a tighter standard than what we do here in central Maine and on the coast. So they're built tight. All right. So as far as heat pumps, people ask me how heat pumps work. Really, the simplest answer is that it's basically an air conditioner that has a reversing valve to it. It can work in reverse. So, basically what the refrigerant cycle, I love to use this example. This is getting into the weeds a little bit, but come join me in the weeds. This is fun. All right. So if you put an air conditioner in your window, we start with the first step here, the evaporator coil. This is the coil that is on the inside of the air conditioner, right? So this is blowing cold air on you. So what people experience as cold air that's being blown on you when you stand in front of an air conditioner, what's actually happening in that is you have this refrigerant that's running through it, and the fan is blowing the heat from the room over that coil to warm it up, to warm that refrigerant up. So we experience is that it's just blowing cold air on us. It's trying to warm up that refrigerant, right? So the refrigerant, it's a little bit like David Banner from the Incredible Hulk TV show from the 80s, right? He's nice and calm. He likes to be relaxed, right? And so as the heat is getting pushed over the evaporator coil, it's picking up heat. It's getting upset. It's picking up energy. And then we go to step 2. The compressor basically adds a lot of pressure into that refrigerant fluid, and it superheats it. It gets it really hot. And at that point, it flashes from a liquid into a vapor. And so I like to use the analogy here. This is where David Banner turns into the Hulk, right? He's picked up so much steam, he's really angry, and he starts smashing everything, right? So number 3, the condenser coil. This is on the outside of the house. The fan is blowing all of that heat that it picked up from the inside, blowing it outside, getting it out of the house. So this is where David Banner turns into the Hulk. He's angry. He's releasing all of his heat. And then once he has smashed everything, he starts to calm down again and start to relax. And then it goes from a vapor back, turns from a vapor back into a liquid, and he's nice and calm and relaxed. And he's David Banner again, and he says, "What happened to my pants?" Right? And then that coolant goes back into the evaporator coil again to then start picking up heat. So that is an incredibly simplistic and goofy way to talk about the refrigeration cycle. So this is what happens in a heat pump. This is what happens in an air conditioner. The only differences with a heat pump is that it has a reversing valve on it, so it can go both ways. It can pull heat from the outside, bring it in, pull heat from the inside, and dump it out. So it can do both ways. You have a bunch of heat pumps in your house already. Your refrigerator is a heat pump. It's just taking heat from inside the refrigerator box and dumping it out the back. So in all houses, we all have some heat pumps in our house already, just different types. All right, easy opportunity for heat pumps. If someone has central AC and they need to replace it, for the love of God, do not put in a new central AC system. You can put in a heat pump that does both. It's like buying a car that doesn't go in reverse, that only goes in one direction. You want a central heat pump that goes on the outside, looks just like this, but can do heating and cooling. So that's a really easy opportunity. You are probably not going to see a lot of central AC condensers. Not really a lot of those here, but I do see some. If somebody has an existing furnace, then you can tie in a heat pump, a central heat pump into that furnace, and you can do what's called a dual fuel system where it has the heat pump and it has the furnace, the oil furnace, and it can switch back and forth automatically between the two. So if someone has the ductwork and says, "I don't like the look of those wall-mounted units," you don't need that. You already have ductwork. You already have a distribution system. You can use that. You have a question about that?
Do they do dehumidification also?
Yes.
Okay, they just don't state it? says heat and AC.
Oh, yeah.
But
Yeah.
are both processes.
Yeah, heat pumps have a dry mode that you can use instead of cooling mode.
Okay, yeah.
Yeah, so the caveat, the asterisk for putting a heat pump into an existing furnace, a couple of things. So that ductwork in the basement better be insulated because if you're going to be running cold air through that, you're just asking for condensation and rust and leaks and all that. So definitely someone's going to need to insulate the ductwork in the basement. And the other thing is like this furnace ductwork here, this is designed to deliver a lot of BTU heating capacity from a furnace. It's not really designed for a much lower BTU heat pump. It's not ideal. If you were putting in ductwork just for a heat pump, it wouldn't look like this size, but it can be used. Okay.
So sometimes there'll be a furnace with a forced air system. And sometimes those systems have humidifiers so that in the wintertime it doesn't get so dry.
Yeah.
First of all, is that needed? So dry that it's a health problem?
The health problem is that you have bacteria soup growing in the humidification unit that is never clean. So I would never, ever recommend having that active.
So you would never have a humidifier with a heating system?
Nope.
Okay, thank you.
Disaster.
I had one.
Yep. Yeah, disaster. I wouldn't recommend that. All right. So how do you size heat pumps? So this is something that Scott talked about. I had mentioned this before. Manual J heat load calculation. This isn't just for heat pumps. This is for putting in any new heating system. The heating contractor should do what's called a manual J heat load calculation. So this is basically taking into account the existing insulation in the building, what's in the walls, what's up in the attic, in the basement, also how much air leakage there is in the house, which the only way you can test that is with a blower door, which we did today. You cannot do a proper manual J heat load calculation unless you know what the air leakage is in the house. Also, it takes into account the volume of the spaces that you're trying to heat. So a lot of times contractors, like if they're replacing a furnace, they're just going to come in, look at the BTU heating capacity of the old one, put in one that's exactly the same, and just keep on going. That is a terrible, terrible missed opportunity. So any heating contractor should be doing a manual J heat load calculation. This is why heat pump installers hate me, except Scott. We love each other, but all the other ones don't like me. Because in every audit report that I write, I am recommending a manual J heat load calculation. Find a contractor who will do it. So Marina was telling me that there are not a lot of heat pump installers in the area who are willing to do that. So that is going to be a roadblock that you might come up against. So this is where you guys have a lot of power. As energy coaches, you can tell your homeowners, heat pump installers are in business to sell heat pumps and put them in. And if they get enough people calling them saying, hey, I need you to do a manual J heat load calculation, they're going to do it. They want to sell you the equipment. They don't want to do it, but they will do it if we kind of bully them a little bit, pressure them a little bit. You have companies like Royal River. They do it automatically. You don't have to ask them. But unfortunately, they don't. Scott doesn't want to come up to Rockport, so you got to use the local guys. Yeah.
Yeah, I have a contractor that I use. I build houses, and I've asked him this time, I need you to do a manual J, and he's like, but I know what this is. And I'm like, yeah, just for my edification, I need a manual J. And what he said is, yeah, we can get the supplier does the manual J. So even if the installer doesn't have the wherewithal, the supplier can.
Yes.
So it's just something to, even if your heat pump guy says, "Oh, I don't know how to do that," you say, "Yeah, well, just go get your wind supply
Yeah.
guy or whoever you're getting your equipment from. They'll do it for you."
The only drawback to the supplier is the supplier did not go to the house, so they have no idea what the insulation is in the walls, the
Right.
windows,
So you have
the
to
attic.
give them all that.
Yeah, yeah, and that's assuming that a heat pump installer is going to get that information. Yeah.
Is that the manual J an actual manual calculation based on measuring the rooms, the width and length and height and every single room, or is there some kind of test that is used like a blower door test to give you data to work out the manual J?
So manual J, if you are going to do it like all by hand, then it's a nightmare, and of course nobody wants to do it. It's hard. It's a lot of math. There are some modern tools that make it a lot easier. There's some different software options that you can use. There's even a product called Amply software that Royal River uses. So you use, you got to use a iPad Pro to do it. But you just walk around the house, and it uses LiDAR to scan the rooms of all of the house, and then it has the manual J software built into it. So you just say, yeah, there's 6-inch insulation in the walls. Yeah, it's double pane windows. Yeah, there's 12 inches of insulation in the attic, and it will do the manual J for you. So definitely don't have to do it by hand. Yep.
A quick question, Colin. Do you ever do the manual J as the energy auditor, since you have an understanding of the house and you did the measurements that go into it? Why does the installer need to do that as opposed to the auditor?
Because I don't want to do it either. Seriously though, Amply software, if I was to use it, it costs me $225 a month as a subscription. I have to buy the iPad, which I have no use for whatsoever besides that. So it's a really significant investment for a one-person operation like me. I have definitely been considering doing it though, because when I do an audit report, I'm always recommending manual J, and then I find out so much of the time that contractors aren't willing to do it. I will always tell a homeowner, if someone's not willing to give you a manual J, just find somebody else. It's that important. Don't skip on that. So manual J, these are the ACA manuals, by the way, the American, oh God, do you know? It's for HVAC. These are all manuals designed to help to more accurately size heating systems. So there's manual S that once you do a manual J, you can plug that number in, and then it'll tell you the size of the equipment you need to put in. There's manual D and manual T that is designed for ductwork for forced hot air systems. Manual H is guidance on how to accurately install heat pumps specifically, because it's different from a traditional heating system. So there are programs in other states like the Mass Save program. If you want the rebate for the heat pump, it requires that you have to do manual J. So like all heat pump contractors in Massachusetts know how to do it. They have to get the rebate. But we are not required to do that here in Maine. We have a much simpler heat pump sizing rule of thumb that we use here, and it is not as accurate. So that's why I will stand up on my soapbox. I have a soapbox, but I'll stand up on my soapbox and push for a manual J, because I come into a lot of houses where, I've been doing this 15 years, and I don't know how leaky a house is just by walking in and looking at it. I don't know. Based on the year it was built, it could have a bunch of holes. It could be pretty tight. I don't know. The only way that you know is with a blower door. The only way. So For new houses, the required building tightness limit is 3 air changes per hour or less. That is pretty tight. So if you build a house to 3 air changes per hour, there really isn't any natural air leakage anymore. It's pretty tight. Regular heating systems like a natural draft oil boiler or furnace, it's not really going to work very well in 3 air changes per hour. There's not enough air exchange in the house for it to really work. People who build new houses that are pretty tight, fireplaces don't really work anymore. I have a friend who designs high efficiency housing houses, and as an architect, she says, please don't put in a fireplace, please. And people will say, well, it's Maine, we gotta have a fireplace. And she's like, no, you don't, please don't put one in. And they do anyway, and then they use it like twice, and they're blown out of the room because it's way too much heating power for a really well insulated house, and then they never use it. And she says, I told you so, don't put them in.
Colin, how does that play out with wood stoves in terms of, is there a low, is there a minimum number of air changes at which you don't want to go below that if you do have a wood stove?
Well, definitely 3. Certainly 3. I would say even probably 5 air changes per hour is getting pretty tight at that point. You can bring in a ducted air system to bring in fresh intake air into a wood stove, but usually what that looks like is a duct that runs in from the outside and then stops right there next to the wood stove. So you just get cold air that comes right in through the duct. So like, what's the point of building a tight house if you're going to put a giant hole in it? Yeah. All right, so also talking about other mechanical systems, we have domestic hot water. You're going to see lots of different options here. There's the tankless coil that is built into the boiler. So if you see this gray box here on the boiler and there's no other hot water heater, then it's probably a tankless coil. So this is where the boiler is heating the hot water on demand. This is a really inefficient way to make hot water for showers and sinks. These boilers have a tremendous heating capacity, a tremendous amount of power just to wash your hands at the sink, Also, with tankless coils, besides inefficiency, the boiler is designed to provide forced hot water baseboard. That's what it does. And it can also give you a little bit of hot water while it's at it. But if you're in the shower and you're enjoying a nice hot water shower and the thermostat calls for heat, the boiler is going to prioritize the thermostat, and you're going to be cold in the shower. So you get really inconsistent temperature. It gets hot, it gets cold. You may find that there's a indirect storage tank off of the boiler. So these are typically about 40 gallons. And you'll see the standalone tank, and you'll see if you follow the water lines, it's connected over to the boiler. So basically, this is a zone off of the boiler. Because there's storage, it's much more consistent heat than a tankless coil. But again, the boiler uses a tremendous amount of heating power just to make some hot water for showers and sinks. So an indirect tank like this can be fairly efficient during the heating system, but outside of that, if the boiler is just running for this, then it still uses a lot of oil. You also, for propane, you're not going to see natural gas, but propane, you sometimes will see these old atmospheric draft tanks where it's like a 40 or 50 gallon tank, and there's going to be a little bell at the top and then the flue where the exhaust gases go up through. You're not going to see these very much anymore. At this point, if these have been replaced, they're putting in the wall-mounted on-demand systems, or they'll put in like a direct vent water heater that isn't open like this. So if you see the hot water heater and this like little bell thing at the top here, That means that it's using the air from inside the house to draft the exhaust gas up into the chimney. This is really easy to backdraft. So if you have people at the house and they're turning on all the fans, exhaust fans in the bathroom, they're running the clothes dryer, you got that jet engine in your kitchen, the 400 CFM kitchen exhaust fan, it can definitely start pulling the exhaust gases back into the house, and then you're just breathing carbon monoxide. So you don't see these very much anymore. Fortunately, they're kind of a disaster. Yep.
We have historically had problems with the sacrificial anode in the hot water tank, which is something we didn't know about until we had to know about it.
Yeah.
Do you want to tell folks about that, or are they no longer used in tanks?
As far as I know, for electric hot water heaters, they have the sacrificial anode. So that's
Do you
something.
want to explain what that is, or?
Probably not very well.
So
I've never had to replace one myself.
Well, it's the tank sets up an electrolysis going on inside the tank, and if you don't, the tanks typically have a sacrificial anode in it, which means that it's a metal like zinc or something that is right down into the tank, and so any electrolysis that goes on inside the tank in the water will corrode that rather than the inside of the tank.
Okay.
And we learned the hard way because our sacrificial anode got all corroded enough so that it started attacking the tank itself and burned a hole in the tank and rusted a hole in the tank. So it's very easy, once you know you have it, to unscrew it and look at it and make sure there's still enough zinc on it so that your tank won't be attacked.
Okay. Yeah, that's for an electric hot water heater. Thank you so much. That was much better than how I would have butchered the explanation. So thank you.
Could you explain what I understand in Europe? There's a lot of heating of hot water right at the source, the kitchen sink, the shower.
Yeah, sure.
What is that, and why would it not be included in a selection?
Point of source hot water heaters. They provide hot water really quickly. Little on-demand units. I occasionally will see them at houses, but really one of the issues is they require a 220 line, which is, people typically don't have they'll have a 220 electric line for their dryer or for the electric stove, but if you want point of source, you typically have to have an electrician come put the 220 lines in, and if you're doing it for every sink, then that just becomes really expensive for all the electrical work. And honestly, an electric or a heat pump hot water heater is probably just going to be cheaper anyway, so I don't really see the point most times. Yep. Marina?
One question qualification there. With the heat pump water heaters, it makes it very hard if you have a house on slab.
Yes.
So the inline gas water heaters for the whole house can be an option there, correct?
Yes. Yeah, that's the next slide here, actually. So heat pump water heaters, these work really well if you have an unfinished area in your basement that you can put this. If you have a house on a slab or a condo, it's harder. It's harder because it does pull some of the heat from the air and it heats the hot water that way. So it does make the room a little bit colder. Rob, you probably find that with yours, right? But you have it in the room with the boiler, so the boiler's producing a lot of heat. Heat pump water heaters, another thing that is a benefit with these is that they're hybrid systems. They have the heat pump built into it, but it also has an electric coil as well. So you can switch it back and forth. So, maybe somebody's worried about putting this in their basement and freezing the pipes in the winter because it's going to drop the temperature. You can just switch the mode over to electric and just use it in electric mode for a couple of months. And then once it warms up, switch it back over to heat pump again. It's not a big deal to do that. Heat pump water heaters do have an air filter on the top. Yes, you need to clean the air filter once in a while. Takes a little work. We have on-demand units like you see in the middle here. So you can get these propane, you can get electric as well, on-demand units. Sometimes people just don't have space for anything else. And so sometimes this makes the most sense. And then we have the electric tank on the right here. Again, sometimes this is going to be the only practical option. Is it the most efficient? No. But, if people only have space for a water heater in like the little cupboard under the stairs, and that's it, then an electric water heater is probably going to be the thing that works. You don't have a lot of options at that point. If the house is on like a little crawl space, you need 6 feet to put in a heat pump water heater. So if you only have 4 or 5 feet in the basement, then it's not going to work. You got to put in probably a little lowboy electric water heater like this or an on-demand system. I'm always trying to get people to move away from fossil fuels. So I don't like to just tell homeowners, yeah, just put in a propane on-demand system. I'll mention as one of the options, if they already have propane, yes, you can do this, but if there's any other thing you can put in that doesn't use fossil fuels, that's better.
I walk into a lot of different homes, probably 20, 30 a week. I'm also from northern Maine, and so I deal with weather. And one of the things that and correct me if I'm wrong, but houses that are especially not occupied in the wintertime, but they still want to keep plumbing charged, I usually recommend a propane heating system to keep the basement heated and keep pipes from freezing. But in a wet basement, I highly recommend heat pump because it acts as a natural dehumidifier just by doing what it does every day.
Yeah. What is it that you do for work?
Real estate.
Ah, all right.
And I'm from Greenville originally, so I've moved around here, there, and everywhere. So seen a fair amount of frozen pipes and this and that. So poor installations.
I mean, when I do audits, like I'm not trying to be a pain in the butt to people. My job is to ask questions. So if people say they want to heat their house and keep it at a minimum temperature throughout the winter and they don't live there, then I'll ask why. Why don't you just winterize it if you're not there?
Frost will push in and collapse the foundation.
Well, that's a good reason.
And just the pilot light alone will keep that frost from pushing in on the walls.
Yeah.
In most cases, unless you're 1800s farmhouse, that's different. But
yeah. Well, I mean, sometimes if people have really nice furniture, paintings, things like that they don't, that they're worried about, and they don't want it to get too cold and have condensation on the inside, then that's another thing. And so I'll ask the question, and if people say, "Here's the reason I don't want to do it," okay, I'm just asking the question. If you got money to heat a house and you don't actually live in it, awesome. That's great.
I deal with a lot of second homes. They all have money to.
All right. So we have the point of source hot water heater here under the sink. Honestly, the only times that I've really ever seen these is in library, in libraries, because they don't. Nobody lives in a library, so if they're heating water at the sink in the bathrooms, then they don't need a water heater tank for that. So point of source works for that. It's fine. If you come down into a basement and you see either the hydronic heating pipes or the water pipes in the basement don't have pipe wrap on them and it's an unfinished basement, I am happy every time I come into that and see that situation because I'm like, yes, I can put this in my audit report. This will give the homeowner something real easy DIY. Pipe wrap is really cheap. It's really easy to install. So you don't need a professional to do this. Rob, your boiler room is technically like right outside living space, and it's so small that like you wouldn't need it in your room. But in an unfinished basement, not too many people have foam pipe wrap on their pipes. I don't know why. It's real cheap. It's easy to do. And, you know, you're just heating all of this water that heats the basement and then doesn't, before it ever reaches the living space, which is what you're trying to heat. Let's see. So also recommending that people set their water heater to 120 degrees. This is the Goldilocks sweet spot for water heating. So if you set it below 120 degrees, you can get Legionella bacteria growing in the tank, and you get really sick. So sometimes people will say, I'm trying to save money on my energy bills. I'm kind of turning it down a little bit to 110 or 100. No, don't do that. It's got to be 120 to be safe. If it's 100 if you crank it to 140, which I see that a lot actually, at 120 degrees, it takes 5 minutes to get scalded by hot water. If you have 140 degree water, it can scald you in 5 seconds. So it's definitely a safety thing. Do not want it to be 140. And also it's costing you a lot more money to heat the water in the tank to that temperature. So don't do that. All right. We have ventilation systems. Let me just go back to forced hot water system. So hydronic here. We have radiant. Oh, come on. We have forced hot water systems or radiant floor systems. People love their radiant floors. People love them. They're so comfortable. You can walk on them, nice and warm. So if you come into somebody's house and they have radiant heat and you say, you should do heat pumps, and people are like, you're going to take my radiant, you're going to pry my cold dead hands off of my radiant floor. I love it. Then don't try to win that battle. That is a lost battle. One thing that you can do that is an option, they do make air-to-water heat pump systems that will feed into a radiant floor system. So you can do that with a heat pump instead of using a boiler. It's definitely possible. It's fairly new technology to the state of Maine. I've seen it. I've seen houses that are heated that way. It works. It's not cheap. Most heat pump installers have never seen that equipment yet, so it's going to be hard to find somebody, but it does exist. Forced hot water baseboard, it is really, really hard to do that with a heat pump. So radiant you can do.
How do you repair, or is there ever repair needed in a radiant floor system? Isn't it all enclosed and covered up, and you'd have to tear the whole thing out?
It could leak. A lot of people, instead of embedding it in the floor like in a slab, people will retrofit it. And if you can get up
Under.
in the basement or the crawl space, then you can put all the tubing in, and it can leak, sure. Yeah.
It would be expensive.
If you see a puddle in your basement and you don't know where it's coming from, then could be that. Yeah. Let's see. Do you guys have questions specific about heat pumps or concerns? Since I used to work at Efficiency Maine, I can tell you I've heard pretty much every possible complaint that people could possibly have about heat pumps because I did the customer satisfaction surveys. And most people were very happy, but the people who were not happy were very vocal about that and telling me all the reasons why they were upset with it. So I've heard them. Yeah.
Could you please talk about the ongoing maintenance needed? There's cleaning the filters, but what do you recommend on an annual or other
Sure.
time interval for maintenance.
Yeah, the heat pump installer that put mine in said, you should have it maintained every 3 years. Does not have to be annual. They said, please don't call us every year. We're too busy. But every 3 years, they'll basically come out and clean the outside system, check the refrigerant charge to make sure that you haven't lost any refrigerant. They'll deep clean the inside unit for you, but once every 3 years, and then I always recommend cleaning the inside air filters every 3 months, every quarter.
Thanks.
Yep.
You mentioned that the heat pump would normally be operating all the time.
Yep.
Either producing a lot of heat or just a little bit of heat.
Mhm.
How can you tell whether it's working properly without that, and it doesn't have a leak in the system,
Yeah.
versus running all the time? Running all the time and that's good, or running all the time because it's got a leak in it and it can't heat properly. How do you even tell?
You can't really tell by looking at it if there's a leak. If basically what the heat pump installers will tell you is if you just don't get much heat out of it anymore, it's just going to be, it'll be just like the air conditioner in your car. After years, then it kind of needs a new charge again. So unfortunately, though, if there's a really low charge and it's running, then it can actually damage the system. So there really is no way to know. And the only way for you to test it is for them, or for the installer to test it, is to actually pull off the refrigerant line and check the pressure in the system, which then loses a little bit of refrigerant charge. So catch-22. Yeah. So that's why it's really important to, like Marie and I were talking about this in the beginning. So I will always recommend that someone get 3 different quotes for a heat pump installation, and then whoever's the cheapest, throw it out. Don't go with them. For a heat pump, you don't want someone who's cheap. You want someone who's going to take time and put it in. The people who installed my heat pump, they were more expensive. I actually saw their invoice versus other people's invoices for the same unit, and I would say, why are they charging an extra $1,000? But then once I saw them install it, and that they took a long time, they were there all day. They did a lot of pressure testing in the lines to make sure that we wouldn't have a refrigerant leak. And, anytime, like I did have one issue with the system, I called them, they were out immediately to take care of it. So I think it's worth it to go with a really good company and not someone who installs heat pumps on the weekend. Yeah.
Okay. Well, I'm involved in an argument that I hope you can resolve for me.
Okay.
And I hope you give me the answer that I want.
Is it with your wife? Because your wife is right.
How'd you know? Yes, with my wife. So,
Always going to side with the wife.
oh no. Okay, so we have put in heat pumps a few months ago, and the argument is this: is it better, say you in the night when you're not in the living room and you have a unit that heats the living room, to just turn it off?
No. No.
Thank you. That's hard to believe. It's not better just to turn it off because then it's not running.
Yeah, so this is a question I got a lot when I worked at Efficiency Maine. It works. It's very different from a traditional heating system where you're going to turn it up and down and use a thermostat and all that. In America, we've gotten trained pretty well to turn the thermostat down at night. With a heat pump, you really don't want to do that because it gets up to speed and then it maintains that speed. It's sort of like taking an 18-wheeler out on the highway. Most of the energy that it uses, the gas, is getting it up to speed. And then once it's at cruising speed, it just kind of coasts right along, and it's super efficient that way.
Thank you.
People will ask about, like, when can I turn it down? When should I, switch over to the oil furnace? When is it more efficient to do that? And, Efficiency Maine over and over says, set it and forget it. Set it and forget it.
Except the problem is that people want to sleep cooler.
Yeah.
So then what? What do you tell them? I'm not. I've been told not to turn my heat pump down, but
Yeah.
I want it to be 5 degrees colder in the evening when I'm sleeping, and then I'll warm it up.
So are you sleeping?
So it's for comfort. For comfort.
Are you sleeping in the bedroom or in the living room?
Well, I mean that's true. That you could certainly design the system so the bedroom is cooler.
Yeah.
But it's something that comes up.
Yeah. One complaint that I heard from people was they put in heat pumps and their electric bill went through the roof, went crazy. Yep. Yep. If you put heat pumps into a house that is not very well insulated, yes, it's going to cause your electric bill to go up quite a bit. Absolutely. So that's why having the insulation and the air sealing done is really important to make sure that these units run as effectively as possible. If we look at this boiler here, right on the first page, 184,000 BTUs, brute force heating capacity. Does not matter if the house is even insulated, it can do it anyway. A typical heat pump system, like say you're putting in two heat pumps, it might be 30,000 BTUs versus 184,000, and people expect it to do the same thing. Like it has more than one-fifth of the heating capacity, and people expect it to do the same thing. No, it's not going to, unless the house is insulated and air sealed, there may be times where it can't keep up with the outside if it gets really cold. That's okay. You have other sources of heat. It can come on for 24 hours, and then you go back to the heat pumps again. That's part of having a heat pump, is trying to get people to understand that it's okay to use other things if you need to, and then put the heat pump back on.
Colin, does it matter whether you use the original installer for the maintenance, the 3-year maintenance on heat pumps, or
That was the question you asked me. Thank you. Yeah, it can be a little tricky. Fortunately, there are companies now that are advertising. We service heat pumps. Contractors typically don't want to do that if they haven't installed it because it's liability. There are great companies like Royal River. There are heat pump cowboys out there who just throw these things in and are out of business in 6 months. So there are some really badly installed systems out there. There is a company called Mr. Cool that you can put in your own heat pump system and install it yourself. Please don't. But obviously that's not probably going to be installed very well. So, like for example, one issue that I came across a couple of weeks ago, I was out on Peaks Island doing audits out there, and one of the homeowners has heat pumps that they had somebody put in. It wasn't Peaks Island fuel, somebody from off island, and so they called that installer. They're out of business. They called Peaks Island Fuel and said, "Hey, will you service them these?" And they said, "Nope, we didn't put them in. We're not touching them." And she can't get anybody else to come to Peaks Island to service them because they didn't put them in. So that can definitely be a challenge. Absolutely.
A two-part question. Is there anywhere that you can get trained to clean your own mini split? And or are there any special equipment needs to do it?
To be honest, I don't know. I'm sure if you go on YouTube, then there are some videos on how to do it.
YouTube University.
Yes. I watched them do it at my house, and one of the things that they did was they used a pressure washer to clean the coils on the outside. You know, a pressure washer right next to the circuit board that runs the whole thing. You know, if you don't know where it is, then I suppose that could be an issue. Yeah. I don't know.
I read recently about someone who is running a business in this area that is just focused on cleaning and maintaining heat pumps, and it said that he had gone through a program, I think at Kennebec Valley or whatever it is, community college, that they have some
There's
training.
a 40-hour installation program that they teach there for free. It's meant for installation, not service necessarily. And not that I know of, no. I don't know, man. DIY. I love DIY. Believe me, but that I'd be pretty nervous about trying to do that myself. Yeah.
There is a filter in the unit itself on the wall.
On the inside unit.
Yeah.
Yep.
Which is very easy to take out and clean that.
Yes.
It's a,
Yes.
fabric.
Please do that every 3 months. Please
Yeah.
do that.
and that's an easy clean.
Mhm.
Besides taking the pressure washer to it.
Right. Yeah. So that was really just for the outside unit that we were talking about. Yeah. Also, if people have heat pumps in an area, like sometimes I'll see heat pumps in a wood shop or something. There's so much dust in the air. You got to clean that filter like every month at least. It just gets clogged, gets gross. Yeah. All right. Let's see. We got some time to do. We can either talk more about heat pumps, or if you have kind of general questions for things that you might come across in when you come to houses, just kind of more general building science questions, homeowner questions, things like that.
5-minute break for people.
All right. So this is really true for old houses, new houses. Ventilation in houses. So we've all heard the phrase, a house needs to breathe. A house is not a living thing. It does not need to breathe. People who live in the house need to breathe. So we are not venting for the house's sake, we're venting for our own sake. Unfortunately, we move into houses and we do a lot of cooking and showering and breathing, and we put a lot of moisture into the air. So we have to get rid of all of that moisture that we're putting in. So, houses would work great if nobody actually lived in them, right? So a house does not need to breathe, but you need to have good ventilation in the house. So if you have an 1850s farmhouse that is super leaky.
Did this last time,
Yeah, okay,
I think. So.
okay, sorry.
But maybe you could talk about the air quality issues tightening up. I don't think we covered that so much on the last session.
Sure, okay. So
Perfect.
signs of tight, underventilated house. So you're typically going to find that where you have the high moisture loads, like in the bathrooms, in the kitchen. So if people have a pretty tight house, this is going to be kind of the canary in the coal mine. You'll start to see mold form in these places, usually on the ceilings. Even in an old house, if they don't have a bath fan, or if there's no bath fan, then you can get mold and mildew in the bathroom ceiling. So in an audit, I'm always worried about, like, if you're going to tighten the house up and do a lot of air sealing work, then make sure that you have adequate ventilation here. If you have a pretty tight house and not enough ventilation, then the wood stoves can possibly backdraft. If people say, hey, I need to open the window every time I use my wood stove, it's a pretty tight house. And then it kind of defeats the purpose of having a wood stove in the first place. If you close the door in the house and other doors in the house pop open, It's kind of tight. Sustained high humidity, mildew around windows. That kind of goes back to the humidification question. With people using humidifiers in the winter, I always tell people be really careful about that. If you're adding humidity into the house, it's going to look for the first cold surface it can find and start condensing and causing mold and mildew. So I've come into houses where people have like a pot of water on the wood stove, and they use that to provide some humidity. And then if you look up at the ceiling, there's mold all over the ceiling. That's actually pretty common. See, moldy furniture. I definitely have seen that from not enough ventilation. There was a house that I did a blower door test that was 4 air changes per hour, wasn't even 3, and she had moldy furniture. Lingering odors, yeah. Let's see, we don't need to do that. I think I mentioned this before. When you have a dehumidifier that drains into a sump hole right next to it, and there's no cover over the sump hole, then the water that sits in the hole just evaporates back into the air. That then goes back into the dehumidifier and then goes drain into the sump hole. So that dehumidifier is running all the time. I always recommend smart indoor air quality monitor with sensors on each floor if people can do it. They're not cheap. I mean, they're much, much cheaper than they used to be, but something like this AirThings monitor here is several $100s for that. That's going to be out of range for a lot of people. But you can get smart digital temperature and humidity sensors for like $25 each, and that just talks to your phone. And if you have high humidity in your basement or crawl space, it'll tell you. You don't have to go down there. Nobody likes their basement. Nobody's going to have a party down there. But if you have the sensor, it's always talking to you. Also, if you come into houses with a dirt floor basement or crawl space that doesn't have a cover over it, like a plastic vapor barrier, definitely recommending getting a radon test. You can do the charcoal canister filter or charcoal canister test that you leave it out for up to a week and then you mail it in and to the lab. That's like $50 or $60. You can get a continuous radon monitor that's electronic for like $90 or $100, and that's going to last for several years, and that will tell you over time what the radon is. That's very useful. So I always recommend the smart indoor air quality monitor, especially if people are having health issues and they don't know why in the house. The smart indoor air quality monitor, it's going to connect to the app on your phone, and it's going to give you data. So over a week or a month or a year, you can watch those numbers spike, and you can go back to your calendar and say, what happened in that week? Why did it spike like that? And kind of put on your detective hat and try and figure it out. All right. Also, gas ovens. This is sort of one of my my challenge questions to builders. Why are you putting in a gas stove at this point? Why? You can put in induction stoves. They are more expensive, yes. But induction, it's faster. It's faster than a gas stove. It's more accurate. So if you have people who say, I love my gas stove. It gives me more control. I feel like I can cook better with it. An induction stove is going to be better. Absolutely, it's going to be better. If you use an indoor air quality monitor, and like if I'm at a house where someone has just used the gas stove, I turn my meter on and the particulate matter, the dust in the air is like through the roof. And it's not something that you're going to smell or breathe or be aware of. It's just with a monitor you can see that. I've been in enough houses where I've shown people that, and that's been enough to convince them, yeah, I think I'm going to replace the stove at this point. Yeah.
We had a gas stove range, whatever, and as an alternative, we got a 2-burner induction countertop,
Yep.
$100.
Yep.
So not what I would call expensive.
Yeah, it's the whole thing. Like if you get the whole, replace the entire range, then an induction stove is going to be more expensive at this point. There was a federal tax credit for it, but that's going away. So that. But there are a couple of states that have actually banned gas stoves for new construction, just because they're so dangerous. They affects the indoor air quality so much, which in that 1850s farmhouse, maybe not a big deal, but for a super tight house, it's really bad. Yeah.
Yeah, that I did watch a interesting video with a university professor who was talking about air quality in tight houses, and she was talking. You know, there's a lot of people think, well, as long as we get rid of all the fossil fuel sources inside the house, we don't need a cooktop. You know, we can use a recirculating cooktop fan, and she was like, actually, no, you can't. You
Right.
need to vent the stovetop, and she showed some statistics about just frying an egg. You know, one fried egg without a venting cooktop was bringing the air quality in the house over the unhealthy threshold quickly.
Yeah.
That's just one egg, and the other issue then is makeup air. If you have a very tight house and you're venting your range, it's required mostly if you're at 450 CFM, you have to have makeup air. But
Yeah.
you know, even for houses that don't have the fancy, you might be thinking about makeup air, which is a little bit complicated, but not, you know, it's not that hard, but it's something to think about.
Yeah, that would be something that, as coaches, I would recommend. If you come into a house with a propane cooktop, then see if the exhaust fan, if they have one, see if it is recirculating or if it's vented to the outside. And I mean, you don't need to be an expert to be able to make the recommendation and say you really, really should have this vented to the outside or switch to electric.
But again, even if you switch to electric, you need to be vented to the outside if
Yes.
you have a tight house.
Yes, but especially important with propane. Yeah.
Can you explain why induction wasn't available and known about? How long has it been in existence? And
Yeah, still fairly new.
I know. Okay, so the whole technology is new.
I don't know enough about it to know why it hasn't been available. I don't know, but I think it's fairly new at this point.
10 years.
Yeah.
We may get a training at some point in the coming year with more details in this area.
Right. Yeah.
And maybe we can shift now to if people have questions that
Oh,
they've
sure.
brought for this evening.
Mine was on the propane idea with stoves. Jumping into heating sources. Obviously, you know, the whole topic now is all heat pumps, but a lot of people have ventless, cast iron ventless stoves. They have B-venting and direct vent stoves. Can you go over some of the pros and cons to some of those?
Sure. So sometimes people have the ventless gas heaters. In my industry, we refer to those as murder heaters because one thing they can produce is a lot of carbon monoxide. So if you see those in houses where they have that little propane stove that's not vented anywhere, that's just venting all of the combustion appliances right into the air, and you're breathing that. And it also produces a lot of moisture as well. Yeah, it's quite a bit. I mean, the byproducts of combustion are carbon dioxide and water vapor, so it dumps a lot of water. You know, sometimes people just have those as a backup in case the power goes out, and that's their backup heat. And so I will say, as an auditor, just make sure that you have working CO detectors, carbon monoxide detectors, at the very least. And I will always ask people, please don't use that. Please, please don't use it. It's so dangerous. Yeah. So, what's that? But, you know, you talk about an unvented propane appliance. That's what this is. You know, this is a ventless propane appliance that's dumping a lot of carbon monoxide into the air that you can measure it. So yes, there are different ways to vent propane or any type of fossil fuel-based heating system. I always like to see the high-efficiency direct vent units if possible. So for propane, that's a great benefit of propane, is that you can just vent it directly to the outside through PVC pipe. You don't have to put it into a chimney, for example. It's just the cost of propane just going to keep going up. You know, of course it will. So that's why I kind of go back to solar panels and heat pumps is, you know, when everybody's complaining about the cost of propane, you can say, oh, really? Oh, I have heat pumps and solar. I don't pay for fuel anymore, so I don't know.
I'll be honest, I've got a 600 square foot house with a big old 1970s Vermont castings visual, and I have to open the windows.
Yeah.
That's my main thing.
Sure.
It's too hot.
Yeah. All right.
I assume that the propane stove venting that just recirculates is not efficient.
Propane for cooking, you mean?
Yeah, they're not vented outside.
Right.
They just recirc through the
Yeah.
filter.
No, definitely want to vent it outside.
Yeah.
It's just blowing it right back, like literally in your face. So no.
Thanks. So I've always just wondered about kerosene space heaters where they say they don't have to be vented to the outside.
Yeah.
Is that true?
Disaster. No, that's also a murder heater. Yeah. So
Yeah.
you can get like you can get a monitor style kerosene heater that is direct vent to the outside. You know, those are relatively efficient. Any direct vent unit's going to be relatively efficient. The propane Renai heaters, they're cheap, you know, relatively to put in, and they're fairly efficient. But no, definitely don't use an unvented kerosene monitor
Thank you.
kerosene heater in the house.
Colin, would you, based on your experience using the indoor air quality monitors in your auditing, would you recommend that our program have one or two of those for coaches to take with them?
Sure.
In terms of helping people realize what is in their air?
Yeah. So I have a portable unit that I use. I think it was like $130 or $150 or something like that. So these AirThing monitors, these are meant to be like plugged into the or using the Wi-Fi in somebody's house. So it's not really good as a portable kind of unit. But you know, the unit like I have, it works. Really, the bigger question though, or the bigger issue is if you have this information and you share it with the homeowner, most people are not going to do anything about it. It's really hard to get people to change their behavior, or you know, people say, whatever, it hasn't killed me yet. You know, that is the attitude that you have to fight back against, and it's hard to convince people. I mean, this propane oven right here was 30% of the explosive limit. There was a huge gas leak in the top of it, and I told the homeowner, this one right here, I told the homeowner, and she just shrugged. Hasn't killed me yet. No. That is not the response you need to give me. Yeah. So, yeah. I usually see the biggest spikes for my indoor air quality meter with wood stoves. If people are using wood stoves, then Yeah, there's a lot of dust on the air. So these monitors, just so you know, I don't think I have a picture of it here, but like this one here, this is going to give you measure the particulate matter in the air. That's basically the dust that's in the air, and it's going to measure two different types. There's PM 2.5 and PM 10. PM 10, it's basically the size of the dust molecules in the air. PM 2.5 is really, really small, and it's small enough that if you breathe it in, it just goes right through your lungs, right into your bloodstream. So that's the really dangerous stuff. If you're using a wood stove, it makes a lot of PM 2.5, and you're just breathing that, and it goes right into your bloodstream. So your lungs are not going to catch it. It's too fine for that. Yeah. Any other questions? Other questions?
For folks that have furnaces and water boilers, can you talk about the maintenance of those, or how often they should be serviced, and if they would lose efficiency by not being serviced?
Yeah. So typically, fossil fuel system like oil, it should be cleaned every year. Oil's dirty. It just kind of gums everything up. It's diesel fuel. You know, most people don't realize that home heating oil is diesel fuel. It's got an additive to change the color, but it's diesel. So, you know, people say like, oh, I wouldn't want to have a diesel car that's really dirty. Your boiler or furnace is running it. People, if you have an oil system, you have to have it cleaned every year, or else it's going to not last very long. It can really run into a lot of problems. If you have a forced hot air system, you have filters that need to get changed every 3 months. I always recommend that for maintenance. For forced hot water, I don't know the homeowner that there's anything you need to do. It's just have it serviced every year. If you have propane or natural gas, it's not quite as dirty as oil, so you can have it cleaned every 2 or 3 years instead of every year. But oil systems will start to go haywire if you don't clean it every year. Yeah.
Hey, Colin, I'd love to hear your, thoughts and recommendations around what we as non-professional energy coaches what are the most important things for us to do during our audits. And you made a lot of comments around the fine line between do-it-yourself versus hiring pros, and maybe what are the pitfalls and recommendations around that for us?
Sure. The line in the sand is always liability. So if you get too specific in your recommendations, then you are liable. And I have great insurance, so I can make specific recommendations and not have to worry about it. But as volunteer coaches, then that's the line that you want to stay away from, is making recommendations that are really specific, of like, hey, you have rim joists that aren't insulated. I think you should use 2-inch rigid foam board and seal it in place with canned foam. Sometimes, sure, you could do that. Sometimes it's going to rot out the foundation, and then you're going to get sued. So, when you reach that line of liability, then qualified professional is like the term that you just keep going back to over and over. Hey, there's some black, looks like mildew staining on the ceiling that might be mold. I'm not a mold expert, but I'm going to recommend that you have a qualified professional come out and check that. You're down in the basement and the boiler is firing, and it sounds like a Harley is driving through the house. It's not supposed to sound like that, but I recommend that you call a qualified professional. I think it sounds like something may be an issue that you need to take care of. So, yeah, I guess that would be the main advice as far as that goes.
It seems like the answer for many homes will be you need to do an energy audit.
Yes. Yes. I love that answer. Yes.
So I'm trying to figure out what can we do to best? Obviously, recommending that and helping encourage that to happen is a good thing.
Yeah.
Are there other things that we can do to sort of clear out the brush that make the energy audit more effective, or get them to do other things in parallel with it?
Yeah, I think like in the work that I've done with the York Energy coaches, I think one of the things that's really valuable that they do is the hand holding, where they'll talk to a homeowner. The homeowner says, "I really want to get heat pumps," and so then they'll talk about that, and then the coaches will call back after a month and say, "Hey, just checking in. Have you been able to find somebody? Do you need some help?" And they kind of shepherd that process along. Whereas when I do an energy audit, I have the time, the hours at the house that I spend. I send the really long report with all the recommendations. People are always open to call or email me if they have questions, but they usually don't. And that's it. I don't call them after a month or 3 months and say, "Hey, did you do any of the stuff that I recommended?" I don't do that. None of us do that. No auditors do that. My job, I did my job. I gave you the report and gave you the recommendations. So I think that's tremendously valuable to do the follow-up for people. As a recommendation, if somebody says, "Hey, I really want to do heat pumps, but I don't know anything about it," you can give them some basic information about it. If they say, "Can you tell me how heat pumps work?" Besides the Hulk, and David Banner, then, maybe you want to have the heat pump installer explain it. But, if somebody says they really want heat pumps, then it's a good idea for you to look at the insulation. I mean, even if it's just like poke your head up in the attic, you don't have to go crawling around all over it. You don't have to go, 10 feet into crawling in a crawl space, but yeah, just take a look. Based on the age of the house, any house built before 1965, probably not going to be fully insulated in the exterior walls. Probably not going to be insulated in the attic very well unless they've had it done at some point. So in order for people to have a really good experience with heat pumps, then you could just take a look at the insulation, see if it looks okay.
All right, great, thanks.
I was just going to add to the insulation in older homes. A lot of people don't know this, but if you see all these little foam plugs in the wall, that means it's been insulated recently. Mm-hmm. They've blown in insulation. I'm not going to say it's good, but it's blown in insulation. It's blown in insulation. So
back to the answer to your question about, if people are interested in putting heat pumps in, should you do an energy audit ahead of time? I would say based on my experience, you're going, I think we ultimately ended up having more heat pumps and more capacity installed in our home than we needed because we didn't do the energy audit ahead of time. So we would have saved, in fact, way more than what the audit's going to cost by having that done, because then you would know. Well, you'd be better off putting more insulation in and sealing it and doing all these other things that would allow you to reduce, you could save, $10,000 on your heat pumps or less, or even more, if you actually did all the other things that you should do anyways to make your house more efficient. So that would be my experience. So.
Yeah, I think we will be, as coaches, will be urging people to sequence, with weatherization and air sealing before heat pumps, unless they're up against like a boiler or furnace that's died and they have to make, occasionally They're going to get out of order, but where we can, I think that will be the recommendation and the way we kind of urge them to go through the process.
If I can go off of that point, one thing that I do a lot as an energy auditor is I'll either look up the age of the boiler or furnace, or they'll just tell me, yeah, it's like 20 or 25 years old. Boilers or furnaces typically last for 20 to 25 years. That's it. That's their expected service life. And so I will counsel people to say, hey, your boiler's getting old. Before you end up replacing it, like having to replace it in an emergency, now's the time to think about some of the heating alternatives so that you don't have to. Because if you replace that oil boiler, then you've just locked yourself into oil for the next 25 years. If somebody has limited amount of money and they have to choose and they just replace the boiler, they're probably not going to then turn around and spend $10,000 on heat pumps.
Another two-part question, or two questions.
Yes.
What do you think the lifespan of a heat pump is? I've been told 10 years.
Yeah, could be 10 or 15.
I'm on year 13, but
yeah. The line that Efficiency Maine would say is that the technology improves so quickly, and the efficiency improves so quickly that in 15 years you're going to want to replace it anyway, because it's going to be like 2 or 3 times more efficient than your old one was.
Really?
Yeah.
Wow. Okay, next question is, you said maybe this afternoon that mice like fiberglass insulation.
Yes, they love it.
Or they love it, or it doesn't bother them.
Right.
What about bats?
Do bats like fiberglass bats?
Are they unaffected also by fiberglass? And what if there is a bat issue?
Yeah.
Can you, and you have fiberglass in the ceiling of a structure, can you augment that with one of the other types that?
I have seen bats nesting in fiberglass, so I guess it doesn't bother them either.
But by adding, I think you said they don't like cellulose?
They don't, no, because it's got boric acid in it. But I don't know if, I've never seen bats try to live in cellulose before.
Can you mix the two? Can you put cellulose on top of fiberglass?
It's not super effective. Usually I recommend taking out the old stuff and just putting in cellulose.
We're going to have one more question and then wrap it up, given we're a little over time.
I imagine that you most of your audits are for homeowners, but I was wondering if you had any guidance for renters. This is a question from some colleagues of mine. We might be coaching folks that are renting their homes. What language should they use to their landlord, who's not paying the utility bills, but is also not living there? And what autonomy do they have? What measures can they do as renters to make their home more comfortable?
Right. So I actually just did an audit last week on peaks for someone who was a renter. And pretty much, the majority of things I would say that I put in the report are things that the homeowner has to make the decisions on. She's got to talk him into doing a heat pump. But she's got electric baseboard heat, which is pretty much the most expensive possible way you can heat. So, but the window dressers program, that's great. That's a great thing that people can do, renters can do. That makes a huge difference.
In the Google folder I sent out today, there are links to a whole series of videos put out by Electrify Now, which is out on the West Coast. And one of them was electrification for renters. So you could look at that as well.
There are also heat pumps that you can put in yourself, not the DIY ones, but the saddle style heat pumps that you can put in the window that renters can use that instead of whatever other heat they have.
The cold climate ones, I think, they're not cheap. They're like $3,000 or $4,000.
Yeah.
But if it's something that's going to go with you when you move, it still might be a worthwhile investment if you're getting really high utility bills in your rental. Colin, thank you so much. This has
Thank you.
been very helpful. And Colin will continue to kind of be, as he is with York, a resource for us. So if you have questions, more technical kinds of questions, feed them to me, and I'll, either we may have occasional sessions with him, or we can just, once we're out coaching and have lots of accumulated questions, we can have Colin back to answer those. So, and we'll have a chance as well, once we're getting underway in the new year, to have sessions amongst coaches to sort of talk about some of the questions and issues that have come up in various visits and get collective thinking on them. So
I love doing that with York. They save up the questions, and then I come and then just rapid fire one after the next. Love it. I have fun doing that. So please, happy to do it.
thank you, and thank you so much for both of these sessions. Very helpful.